Welcome back. In this video, we'll examine one more case of bizarre behavior that you may encounter in SQL when dealing with floating point numbers. Let me start with an example right away illustrating this strange behavior. Let's go to the IMDb database and let's say that we are trying to find movies that have a rating rank equal to 7.8. We go and we write the query. Select star from movies where rank is equal to 7.8. Execute the query, you'll see that you get nothing back. Okay, strange. Now let's go and change the condition. We're going to change the condition and write where rank greater than 7.75 and rank less than 7.85. Get back the results, you'll see plenty of movies that have a rating of 7.8. Bizarre? Try to run the equality query again, you'll see that you get nothing back. So plenty of movies with 7.8 rating, you run the equality, you get nothing back. Run the inequality query and you get back what you expect. So what's the issue? Why do we see this very strange behavior? Why this thing happens? Actually in SQL and in reality actually in many computer languages, whenever we store decimal numbers, these numbers are not really stored the way that we see them in decimal format. They are stored in binary format, a combination of 0 and 1s. What is going on now? Binary numbers cannot always represent decimal numbers with perfect precision. The binary numbers are very close to the decimal ones, but they are not exactly the same. Let's see what happens to the 7.8 number that we used before. The number 7.8 in binary, it is written as 111, this is the 7 in binary, then decimal point, and then 1100, 1100, 1100, and so on at infinity. Of course, we cannot keep infinite number of binary digits. Computers have limited capacity, so we typically keep around 30 to 60 of these binary digits for the decimal point of the number. If we try to convert this binary number back to a decimal, this converts back to the following decimal number: 7.8, 00, 000, 190, and so on. Very close to 7.8, but not exactly the same. Now, depending on the number that you have and the binary representation, sometimes it is slightly larger, sometimes it's slightly smaller, sometimes exactly the same. You don't really know beforehand. And because rank is stored in a database not as an exact number, but as an approximate decimal number, we can often encounter very strange behaviors when attempting equality and inequality operations. So for example, if you try the following query, select star from movies where rank greater than 7.8, greater than, not greater than or equal. You get back movies with rank 7.8 even though we have a strict inequality in the condition, right? We don't allow rank greater than or equal to 7.8, we only allow rank greater than 7.8. However, because the rank 7.8 is stored in the database as 7.8, 00, 000, 19, and so on, we get back this strange result. Now, how can we resolve the problem? One of the rather unorthodox ways of fixing this issue is to use the like operator, which we examined previously, which can resolve the issue for at least the equality queries. Interestingly enough, like works in MySQL to compare against numbers as well. So for example, if you want to get movies with a rating of 7.8, you can run the following query, select star from movies where rank like 7.8. You run it and you'll get back the movies that have a rating of 7.8. Moving forward, keep in mind that whenever you are trying to deal with decimal numbers in a database, you may face some peculiarities. There are different ways that you can resolve this issue systematically, but they are a little bit more advanced and they don't really belong in this course. I just want you to have this knowledge in your head and don't be surprised when you run into such strange behaviors in a database. That's it for the floating point bizarreness that you may encounter. Let's move to our final video for this session, when we're going to try to write a complex query trying to deal with a common problem that appears in databases in practice, dirty data. Until then, play around and practice. See you next time.